Think about the most creative thing you've made. A moment in your life where time disappeared and everything just clicked into place. What surrounded you? A tight deadline? Limited tools? Or maybe a seasonal theme that you must base yourself on in a project? It's not a coincidence that these sets of limitations help you focus, and it all comes down to one math concept: linear programming. It's a branch of math involving linear inequalities that most people are very familiar with in high school. You probably felt annoyed by the pile of restrictions that were on a project. But at the end of it, you probably walked away prouder than the result of anything else that you've created. Maybe that one project is the reason why you believe you have creative potential. So the years pass by you and you start chasing that same creative flow without knowing what actually produced it. So you hypothetically want to cook, and you head to your stove with the laptop on the table and all the cookware, vegetables, and meat at your disposal. You don't set down many rules for this cooking session. Your imagination feels translatable onto the plate until you suddenly have every single possible dish available at once in your imagination. So you start scrolling through reference dishes, then more references, then even more, until you have 30 tabs open with nothing on the pan. The decision fatigue kicks in, and the freedom that you have now, which you thought benefited you, now goes against you. This type of failure, however, can be demonstrated through the lens of a mathematical concept. Linear programming has an answer for why that failure happens, and it runs on just two simple ingredients. So, what's the objective? The objective is simply the goal, the one thing you're trying to maximize or minimize, and picking the right one matters much more than what we'd expect of a goal. Let's say that you're going on your first date. When you set up an objective, making the other person fall for you is generally a bad move, and there's no telling a person's mood when they show up on a date or whatever relationships they've experienced in the past. A good objective, however, would be to minimize awkward silence. So, you start asking questions that you're genuinely curious to know about, and the chemistry can skyrocket from there. Because, you know what? The worst thing that can happen on a date is probably not being able to say anything. So basically, my point here is that a good objective always has to live inside your own control, and it has to be something that is measurable, or otherwise the whole plan crumbles before you even get to the constraints, which is my next point. Once you know what you're aiming for, the next concern is what you should limit yourself to. A 2014 study on real research and development teams can be quite useful here. Organizational researcher Brent Rosso spent months embedding for teams inside a massive multinational company, Gigantech. The constraints these teams dealt with will split cleanly into two categories: process constraints and product constraints. Process constraints control how the work gets done. This could be things like time, budget, equipment, and available staff. Product constraints, on the other hand, control what the finished result has to look like. This can be things like required specs, customer needs, and business skills. But here's the part that nobody expected going into this research. Process constraints, or the one about time and resources, tend to hurt the team creativity the most. Product constraints, on the other hand, the one pinning down exactly what the outcome needed to achieve, tended to boost creativity instead. It makes sense once you sit with it. It narrows down an impossibly huge pile of options down to one specific target while leaving the actual process wide open. One engineer in the study said that hitting a well-defined target doesn't feel so constraining simply because there were so many ways to get there. Rosso also found that the constraint has to feel real to actually matter, since one team completely ignored an aggressive deadline the moment they suspected the manager wasn't serious about it. The amount of constraints matter just as much as the type of constraint. Teams facing either extremely tight limits or barely any limits at all were both less creative than the teams that were sitting somewhere in the middle. So now you have two ingredients on the table: your objective serving as the goal, and the constraint serving as your limiting boundary, while both work simultaneously. Mathematically speaking, here is a graph with two axes on it, and each representing a decision variable. Every constraint you add becomes a straight line across the graph. cutting away at whatever option breaks a rule. What's left over, the space where every single constraint is satisfied at once, is called a feasible region, and it's the only place that a real solution can exist. Without constraints, the objective becomes what mathematicians refer to as unbounded. In linear programming, a region that never closes usually means that the objective can keep climbing forever. This is basically the math version of decision fatigue. But without an objective, you don't have a direction since every option looks equal when there's nothing to measure against the option. The actual discovery behind linear programming is that the best possible answer never sits in the open middle of that region. It always sits in the corner exactly where two constraints cross, that corner point being the vertex of the graph, which is the closest thing that can be referred to as the float state in math.